three scenarios: moving all data files comprising a table space, moving an index within a data file for subfile DST, and also moving a table within a data file. So for this demo, I've got a few scripts with a prefix that I'll be following just to kind of show the flow of the steps that we're going to use for the three scenarios. Before I get started with that, I'm going to set up a tail of the alert log for the database so we can see any changes that take place in the database as they happen here. And then also, for dynamic storage tiering or SmartTier to work, we have to have some information from the data dictionary of the database. So we set up a little repository that will store information about objects that are in the database, their offsets, and the extent information within the database, and how that maps down to file system extents. So what we have to do is we have to set up a little repository. So I've got a script that will do that, and I actually have an existing repository. It's going to move it aside and recreate it. And incidentally, the command that's used to update the repository is the same command that is used to create the repository from scratch. So here's the command. You'll see that I moved the original out of the way, and it created it from scratch. It noticed that it didn't exist. It couldn't update it, so it created a new one. So now what I'm going to do is I'm going to shut down the database just temporarily. This is a one-time setup operation because I have to convert the traditional volume to a multi-volume file system and then remount the file system on top. So we'll see this activity in their alert log as we shut down the database. And instance shutdown complete. So now I'm going to unmount the file system as the root user in this right-hand window. I'll actually show you the volume before we do the conversion. So it's just a traditional volume with a single plex, single subdisk. I also printed this second volume because to do the conversion from a traditional volume to a multi-volume set, you actually have to have two volumes to do that. So here's the conversion. So now you'll see I have a VT record, and the volume is associated with the VT. I have this script from engineering actually renames the original volume with this extension B4 VSet. And then when the VSet is created, it takes on the original volume's name, so you don't have to update your mount tab or anything like that. It'll mount back exactly the same way that it was mounted previously. It's just now on a volume set as opposed to a traditional volume. So the file system is mounted again. And now I'll restart the database. And the database is open. So what have we done here? We've created a dynamic storage tiering multi-volume file system. And currently, the classification of these two volumes is just simply primary and secondary. So what I'm going to do is I'm going to customize that with my own names. I'm going to classify these volumes to both be of the solid state tier. And I'll show that information again. Run the show fs command again. So now you can see that both of these volumes are in the solid state tier, whereas previously they were in a generic primary and secondary classification. So the next step is to add a tier to the existing set. So we have a solid state tier. Now we'll add a second tier. And a third tier. So a Symmetrics and a Clarion tier. And we'll actually show those tiers at this point. So as these volumes were added, I classified them as the name in. This is the volume name, and the second portion is the classification that we added. So now you can see we have a three-tier configuration. We've got two volumes where all of my data is stored at this point in the solid state tier, We have a Symmetrics tier and also Clarion tier, which really is nothing being used at this point in either of those two. These are alphabetized, by the way. So now what we're going to do is show a table space. We're going to map out a given table space to show where it resides on disk. There's a couple of ways to do this. In this little script, it runs those commands and echoes them to the screen so you can see specifically where this particular table space, it's a partition table, where it lives on the tiering arrangement. We know it's going to be in solid state, but we're going to demonstrate that here with this script. So it's a products table space, and you can see that all of the data presently resides in this solid state tier. And if you want to know the specific volume, you can run this fsmap command with the -A switch, and it'll tell you what volume the data presently resides. So the point of this is we're going to move this given table space wholesale from the solid state tier to a different tier. So here's the move command. So it's a one-liner. Here, table space move. Actually, I ran a policy report here to show that there is no policy present. And then after this move, you'll see that there is now that we have a policy. So when you allocate new files of that table space, they will follow this policy, and they'll be placed into the Symmetrics tier. So that table space will stay together. So now we'll again run the map command to show the changes that we've made. Now you can see that this entire table space has been moved to the Symmetrics tier, where it previously resided on solid state. I'll scroll up a little bit to show you that that was solid state previously. You can also see that these are residing in the subvolume called Sim1. Remember, it's a multi-volume file system. So now I'm going to look at an index, scenario 2, one index of a given data file, and just move the blocks that represent that index. But first I'm going to map out the index to show where it lives on disk. So here's the index, if you will, the particular area, and it lives on solid state storage presently. Sorry. I'm going to move just that index and nothing more. And then show the change. So you can see for this one index, it now resides on Symmetrics. But take a look at the object view for this data file. You'll see now the data file resides on two tiers. What we did is we created an extent within file system, or at least we made a subdivision of the extent to match that particular index within the data dictionary of the database, and I only moved those blocks. So the first thing was to take one large contiguous extent and then divide it down into three parts. And then once I have that extent in the middle that represents this one index that I wanted to move, then I can move that extent to a different tier or a different subvolume, if you will. So that's exactly what we've done here. This is demonstrating that if you accidentally create an index in the regular table space, there's a way to repair that without downtime. Typically, this is a very common oversight for a DBA in that they'll create an index and they forget to add the table space clause to the create index syntax. And when they do that, the index doesn't go into the appropriate table space. So this is a way to fix that so you can move it to the appropriate tier if they have tier classification for their index objects. So now we're going to move on and do the same thing for a table. So the given table itself is a component of a larger data file, and there's many objects in that data file, database objects. And I'm just going to pick out one particular table and only move the blocks that represent that table. So first I'll show where the table lives presently, and as you can imagine, it's on solid state at this point. And now I'm going to move just the blocks that represent the table. And as I said, for a given extent, if the extent is larger than just this table, the first thing we're going to do is we're going to separate that down to extents in the file system that represent just the table, and then move that extent. So now you can see that this table resides on Clarion, whereas previously it was on solid state here. And now you can see that this given data file, this one data file, there's actually 4 parts to it. The first portion is the original portion. There's other objects not associated with this table or index that's still on solid state. My table I moved to Clarion storage, lower classification of storage. In the index I moved to Symmetrics. And then the remainder, the balance of the data file still resides on solid state. So this demonstrates subfile DST.